Okay, well, thanks and welcome. I've been asked to do the science first, so the science and the demonstration. So this is the ShowerPowerBooster, and this typically is a power shower, and to replace that pump you need two of these, one on the hot, one on the cold. About 80% of people simply boost the hot, but 20% will boost both the hot and the cold. So the device itself, typically in a home, you're going to have 1 meter head to the tank on a gravity system. The minimum pressure for a lot of shower heads is 1 meter. This is adding 2 meters, 3 times the minimum, great shower. If you have more pressure, you don't get a lot more benefit. And that's why we have the highest approval rating of any pump in the UK, with 5-star excellent on Trustpilot. Now the science. This would be absolutely useless if it fits on an existing pipe, and then you have a power cut, and then you don't get any water. So the way this works, there's a non-return valve which is back to front. And when this pump kicks up, it produces a pressure which closes the non-return valve. So the pressure this side is pretty much nothing, and the pressure this side goes all the way up to half a bar. Well, I tell people half a bar, it's actually more than that, but then you know what people are like. So it's a half bar pump, but you only get the half bar if you need the half bar, and you only need 2 or 3 meters anyway to give you a good shower. So there's a lot of leeway. When the pump kicks off, it closes that valve. You've got a differential of pressure either side, which allows you to use the pump which is most efficient at 6 litres a minute. This pump is probably more efficient at some crazy figure way, way above. If you had that pump running, you wouldn't hear yourself speaking. It would be wasting energy like billio, but plumbers like big pumps. It's almost like a competition. In fact, on Dragon's Den, Deborah Meaden's got an 8-bar pump apparently. But anyway, so there's this battle for big pumps doing more than a little pump. You don't need a little pump. When you've got a little pump, it doesn't burn out, it doesn't cavitate, it lasts a long, long time. One of my problems is that people who bought these back in 2012 have still got them. Now, it really took off when we invented the flow switch, because unlike a big pump which sits on the ground, that operates through a bullet, and the bullet is trying to fall through gravity, and the flow is coming the other way. So the flow is determined by this bullet moving up and down. But if you move that to the side, the bullet jams. So I needed to come up with a flow switch that worked in that direction, any direction. Because people's plumbing it's all different. So I took a magnetic water wheel, which was used in scientific application. And this water wheel spins, and it can tell you how much flow is going through. I don't really worry. As long as there's 1.5 litres a minute, the magnet, which tries to think it thinks it's a compass, it's trying to align to magnetic north. At 1.5 litres a minute, it gives up and it spins like billio. And when it spins like billio, the light flashes rapidly. And the light is a diagnostic. So if it flashes slowly on and off, it means you got some sort of electrical issue, because it's setting and resetting, setting and resetting. If it flashes rapidly, then its water wheel is turning. If it isn't flashing, then you've not got 1.5 litres a minute. It waits 2 seconds to make sure you did really want a flow. And then if you have a bubble move in the middle of the night, it ignores that. If you really turn the tap on or turn the shower, it turns on. So that's the pump. And it's got lots and lots of applications. It's sort of growing. In the early days, and I haven't brought one of the old pumps because you'd say, what the heck? And one of the early pumps actually lost me the Dragon's Den because it was a prototype sort of thing. We now test our pumps to 8 bars. That's 80 metres head. And the reason we do that is ours is the pump that works in any and all applications. If this leaks, my question is, how big a hammer did you hit it with? Because we've just made it bomb-proof. And what temperature rating, huge. It'll take boiling water. And I'm going to move on to the presentation because the applications of this pump are very wide, but I'm not going to dwell on the applications because everybody's interested in their own application. If you've got an electric shower and you want to boost that, the last thing you want me to tell you about is a combination boiler. So don't expect more than about 2 seconds per slide, just to give you a flavour of the applications, and then I'll ask for questions. So, if I've got this right, we have 2 pumps. This is the fully automatic. This is the mainstream, and 80% of people just buy that. In fact, if you're, well, that's that. So, this is a manual pump, and it's slave to the automatic, so you can double boost if you want. So, there are situations where you would want to double boost. That's the double boost. It actually comes with one fully automatic pump and a slave pump. For those that require 2 pumps, and some mixers, particularly mixers from a bath, need 2 pumps. If you're unfortunate to have that, you'll need to boost the hot and the cold. So, a single pump can boost every tap and shower in the house. That is the most common solution. It's £125. It takes 10 minutes to fit it. Job's a good one. Then, double boost. This is more applicable if you've got mains pressure on the cold. So you might as well double boost because there's only an extra 30 quid for 2 pumps. So we price it so we make the money on the first pump and the second one, well. There's the bath. You'd need 2 pumps for under a bath. Protected flow. This is amazing because water would like to go by the easiest path. So if you've got a shower upstairs which runs hot and cold when somebody opens a tap or flushes the toilet, you can fill the water because it'd rather go into my pump than out of a tap. So you put the pumps just to supply the bits and pieces rather than the whole house. If you have a pipe which originates at the bottom, you can put air valves in place of the pump in the loft. Another way of boosting a bath, if you're changing a power shower, then you might as well use the existing fittings and just put the power shower where the shower power booster where the existing pump was. You'd need 2 pumps, the SP22S. Combi boilers. If the combi boiler's dropping out due to low pressure, put them before. We have the only pump that will work on the hot side of a combi boiler. Because of the temperature and pressure rating, there's no other pump that will work on the hot side. This would be a protected flow type situation where, despite the combi boiler supposedly giving you good pressure, you've actually got a real problem. Solve it with a pump. Electric showers. Quite a big use actually. If the pressure falls below a minimum, normally between 7 meters and 10 meters, you can boost the mains pressure to make sure it continues to work. Unvented cylinders. Again, everybody thinks there's no problem with unvented cylinders because the pressure is mains pressure throughout. Well, just tell all the people who buy our pumps that isn't actually true. They'll disagree with you. Mains pressure boost, to boost the pressure coming into the main house. There's not a lot of room under a sink, so use the dog leg to get 2 pumps in. We boost radiators. So if you've got a lazy radiator which refuses to get hot, we make it get hot. We make it get hot. And there are 2 sorts, one which is an online and one, having trouble with the machine here. And one, here we go, which fits on the radiator itself. So there are all these applications. I'm not going to go through them all. Argas, wood burners, Fortic tanks, close coupled tanks, instant hot water at taps. Basically, we use the pump in so many situations. There are some more situations there. All of these are in the manual. I'm going to make an interactive manual where I talk on each one, because if you've got a problem, you'll only be interested in your problem. And I say, if you haven't got a problem, the thing is an eco device. It'll physically deactivate. So if you've got 8 litres of water and you think, wow, I'm going to have 10, 12, the thing will realise that you haven't got that. You've already got enough water and deactivate. And that's it. And one final thing to show you is so that pump has been running along. It's now going to get quieter, as you see, because the noise of the shower is normally twice as loud as the actual pump. And this is the essence of why it got the patent. It deactivates when you exceed the capacity of the pump. So it's now stopped. The water's still going through. So it went to 0 and it went up. And the other thing, just to prove to you the power, torch battery. I don't know how I best show this without being in the way. And that's the power from a torch battery. And it does all of what it does with 1/20th of the power of a big pump. And over 1,500 customer reviews, 83% 5-star. It does what it says on the tin. And it works, but it's so difficult to sell this to a traditional plumber. In the early days, we put it in a box So we put it in a big box so people didn't know how small the pump was. And that was the advice from the UEA, or at the UEA. And at the time, that was good advice. But then people used to take them out of the box, and this invention is out of the box. It's unconventional. Thank you. And I'd like to take questions. Let's unplug my torch battery.
Any concerns for hard water or scale compared to, like, is there an advantage here?
None at all, because scale is produced when you drop the pressure of water. This increases the pressure of water. Scale has never ever been a problem. The only problem has been scale which comes with a shower, because what's happening, the pressure of the shower is greater than the pressure when it gets to the nozzles. So when the pressure drops, the lime scale drops out. And one thing I want to mention is none of this works without a decent shower head. And I sell shower heads, the Right Choice shower head. And that was developed, or that was discovered by me in Cranfield University when we were doing the validation in our laboratories. I found a particular shower head that worked really brilliant, so I decided to sell it as part of the package. So, yeah, no, lime scale really isn't a problem.
Does that include the internal bore of the shower hose as well? Does that need to be bigger than what normally comes with the shower?
I won't mention a name, but there's a particular shower mixer where they really produce a ridiculous shower hose to go with it. So the only way you can get the 1.5 litres to start with is to put a bigger shower hose in and change the shower head. But once you've actually got the thing going, the flow, you're best to have a 10mm minimum, but 8mm doesn't make a huge difference depending on your system. But the shower head is the most important. So if you were in India, they wouldn't touch, they call this a medical shower, and they sort of have 20, 30 litres of water like Niagara Falls coming out, so they can say to people, oh, look at my shower. But if you want something which is economic, a good shower is 6 litres of water a minute. It's enough to wash the suds away. Any more than that, and you're spending money heating water and wasting water. Any less, and you spend longer in the shower. So there's an optimum, and that's why I designed the pump to be at the optimum. It's the sweet point, where any bigger it's wasteful, any smaller it's wasteful, because of the time that you need to shower.
So does that mean also that the existing pipework, what that pump could go on to, it works more efficiently with 15mm pipework?
It does actually.
Yeah.
Depends what you're doing. If you've got a bath where you want 20, 30 litres of water, always put a 22mm. But once you get to the sort of flow rates for a shower, the situation is that the head loss on a 15mm is minimal. In fact, you cause problems by putting 22mm in, because if you put 22mm in, the water isn't flowing fast enough to take the water with it, the air with it rather. So the whole thing gets air entrainment, and the efficiency goes down, and you get these bubbles of air moving about. So this plumber said, oh yeah, we're going to put 22mm in. And it's a couple of weeks ago, he had all these problems. I thought, well, they're all under the carpets. You can't do anything about it. This guy is crazy. Why on earth did he put 22 to all? In fact, a lot of his stuff was 28. So bigger is not best. That applies to pumps. That applies to pipes. You've got to get your right size for the duty, and then you hit that sweet point. Yeah.
smallest size it'll go on to? I'm thinking my central heating pipe is, I don't know,
8 mil.
probably 8 mil, yeah. Do you adjust your plumbing? Or do you?
Yeah,
is that
we
on site?
use reducers. The minimum size for ShowerPowerBooster is 22 mil, and we reduce that down to 15. The radiator boosters come standard at 15 millimetre, and then they easily reduce down to 10 millimetre with a single reducer.
Yeah.
But then if you want to get all the way to 8, like our Wilcon home where we live, you really need to put an isolating valve type reducer to get down to 8 mil. And 8 mil's a pain. But yeah, you can reduce it right down. Anybody want?
Yeah, so our boiler is a Combi boiler, isn't it, darling? So but it's on the same level as the bath and the
Yep.
shower. Am I right in thinking that we don't need the power shower booster because we're on the same level? Because the boiler's on the same level as the shower and bath.
The level for a combi boiler is almost irrelevant
It's irrelevant.
because your pressure coming in is 1 bar, 2 bar, 3 bar, typically. And the shower bar booster is going to be producing half a bar at its minimum flow, probably less than that. So you only ever fit the shower power booster if you've got a problem. If there isn't a problem to solve, it won't solve it because there's no problem. So if you've got 2 bars coming into your house, 2 things will happen. One thing is the combi boiler will be above 1 bar, which is 10 metres head. If it was less than 10 metres head, it actually has an anti-kettle device which turns the combi boiler off. So if your boiler isn't turning off, do not fit shower power boosters before it because there's no problem to solve. Probably the most effective use of a pump with a combi boiler is if you've got a real problem. That is, you've got a shower or a tap which suffers when somebody else uses a tower and a shower or a tap. And you reprioritize it because water would rather go into a pump than it would out of a tap. And the last thing it wants to do is go out of a shower because it's got to push its way through those jets. So like a load of children, they don't want to go through a shower head. So you fool them. You put this pump. He goes, oh, I'll go into a pump. And once it gets the other side, there's no way back. So if you've got one of these problems, then it solves it. And, well, that's it, horses for courses. Now, the manual will tell you when to use it and when not to use it. And probably my biggest problem is to stop people using it when they haven't got a problem. But they shouldn't really be looking to buy my product if they ain't got a problem. But if you've got a problem, any problem on any system, this will solve it. You may need to double boost. You can even triple boost. But there's a limit to you know, eventually you probably need to solve the problem.
Okay, thank you. Can I ask about the science as well?
Yep.
It seems to me you're talking about the mechanics of it rather than the science, but can you explain to me a little bit more about the electrical,
Was it
the
magnetic
magnetic fields?
The wheel.
The wheel. So, okay.
In what way does magnetism affect the product?
It's purely a flow switch. So, as far as I'm aware, and according to the people who sell the magnetic wheels, they confirm this. I am the only manufacturer who uses a magnetic wheel as a flow switch. Other people use it to measure, but I use it just to turn on and off. So when the wheel turns, there's a little wheel in there, and half of it is north and half of it is south. There's 2 magnets stuck together. And when it spins, you've got a hole detector, and it's monitoring this little magnetic wheel, and it goes north, south, north, south, north, south, and it waits 2 seconds just to make sure you really did want water, and it's not just an air bubble moving. So it says 2 seconds, north, south, north, south, north, south. I'm now going to turn the pump on. And then the pump will stay on until you turn the tap off or the shower off, and then the water's got nowhere to go. So the water stops, the flow falls below 1.5 litres a minute, the wheel stops turning, and the hall detector says, well, I'm wasting my time here, there's nothing going north, south, turn the pump off. So it's as simple or as complicated as that, but it does mean that my flow switch uniquely can go in any direction, anywhere.
Thank you.
Alan, could you explain what comes in the box, please?
Okay, so...
I have another question when you got the...
Okay, very quickly, you get everything to do the job. Unlike big power shower where you may need an Essex flange and loads of extras, you get everything to do it. So you cut 110 millimetres of pipe. If that's 22 mil, you just slip it straight in, tighten up the joints, plug it in, job's a good one. If you got 15 millimetre, it comes with couplings to do the job, that's the end of it. So unlike other pumps, £125 gets you everything, £200 for 2 pumps, £155 for a double boost, and it's simple. And we have lots of do-it-yourselfers who will do this, and plumbers who appreciate giving a low cost to their customers also do them. Adam's one of 5 plumbers in Norwich who actually fit my pumps on a regular basis. Adam.
So it's something that this gentleman said, combi boilers, and the classic, you've got a kitchen tap on, you have a shower and pressure drops.
Yep.
So the solution to that is put the pump on the cold going into?
No. Does the combi boiler drop out because of low pressure? If the answer is no, it doesn't, you don't put them before. If the answer is yes, it will support a shower. So the combi boiler will continue to run. But if you try and run 3 showers, it'll give up the ghost and say, look, this guy's after too much water, I'm going to turn myself off. So you put it to protect the flow. So it's got to be on the pipe that feeds just that shower, or just that shower and a tap, and the customer knows not to turn the tap on at the same time as he's showering. He clips his wife around the ear hole if she does. Or the husband, sorry.
Thank you.
Yeah?
Yeah.
But uniquely, it's the only pump with the pressure rate and the duty which will go on the hot side of a combi boiler. There is no other, because it just couldn't take the duty.
Does your pump have a thermal cutout like standard pumps do?
No.
So it can take any temperature?
We use it for boosting the hot water from a back boiler at our house, and virtually every other night it boils, but it does no harm to the pump. The automatic shouldn't really have temperatures above 85 degrees C over a protracted period. It'll take a hot water surge for a short period. The manual regularly on solar thermal systems will take temperatures up to boiling point, no problem.
That's good to know.
But again, it's, see, I'm an engineer and I do crazy things unlike accountants. You know, if it's an extra 5p to get a temperature rating of 125 degrees C for the circuitry, which it has, I pay the 5p, to hell with the cost. Whereas other people would say, well, the maximum you're going to get on a normal system is 60, 65. So let's save the 5p. But I'm an engineer, I'm not an accountant. So that's why we test it to 8 bars when you're not going to get anywhere near it. But it doesn't cost a lot of money to make a really robust pump. And it gives you the peace of mind that you're not going to have issues with it because you've over-engineered it.
On a back boiler, you usually have 28mm pipe running from that
Yep.
circuit. Do you have a pump that will take it 28mm pipe?
You'll simply reduce with, you can either get a 28mm coupling with reducers down to 22.
For just that short run, or would you do from 28 to 22 all the way up to the header tank?
No, just do that short run. Because, I mean, what you're trying to, the situation where you'd need a 28mm pipe is normally sort of a very large house. In normal domestic, 22 is about the maximum. So
Yeah, I've just got a situation where I want to feed it to a Gledhill torrent tank. So their tank's sort of like a heat battery type tank.
yeah, heat store.
Yeah, so you're not sort of pumping it around the whole system, you're just pumping it to that tank and the header tank.
I've got a new product which is about to be launched, which I think will interest you.
Like
Yeah.
okay.
I haven't even got pictures of it yet. But I'm always inventing new things.
Next year, or what time next year you say?
Probably next week.
Oh, okay.
There's a guy who wants to buy something. The guy wanted to buy something which I didn't have anything to sell him. And I thought, it's like the 5th or 6th guy had asked for this particular product. So I just got my thinking cap on, and there's a new product. I went to the factory to see about manufacturing on Friday, and I asked for a special fitting to be made, and he said we already make that fitting, so it's going to be sooner rather than later. So that will be announced very shortly.
Yeah. Okay.
So give me your details. My contact number is on
Yeah.
the website, Alan Derrick Wright at
I'm on
iCloud.
my 3rd pump of yours, so I'm quite happy with that. So.
Right. Are you one of the 5?
No, I'm the extra one.
So you're a 6th.
Yeah.
Now, we have lots of plumbers in the area, and I think one of the things that the plumbers get is you're paying for service. So if you've got an issue when you're fitting it, or an issue after you've fitted it, and even if you've got an issue 6 years after you've fitted it, or 10 years after you've fitted it, we still sort of give you the support. And we sell individual components, so if the only thing you need is a transformer, we sell a transformer. And everything from 2012 is compatible with 2022. So we haven't changed any of the connectors, but the pump has changed through all recognition, because I wanted it to be something that would go in Argas and wood burners and combi boilers and anything and everything. And when you put all that effort into a tiny pump, it's not that expensive. If you tried to put all that effort into this pump, because the surface area is proportional to the square, you know, it's pi r squared the area. If you double the size, you've got to have 4 times the pressure or the strength pushing back. So big is not beautiful. And I hope I've demonstrated that tonight. Well, to you I have already. Thank you.
So at Dragon's Den, the fallout, so you didn't get picked up then. Do you think it was positive or negative or neutral connotations afterwards? Do you think despite you not getting it, it was still beneficial?
It was like going to the dentist for the first time. You'll never forget it. And a lot of the things aren't what they seem. But the manufacturer I was working with was so... they'll probably be watching this. I couldn't work with a better company. But they were very keen that I continued to work with them. So we agreed a manufacturing deal just before I went on to Dragon's Den. And I don't know if I would have got that without Dragon's Den. It's just that extra incentive to get them signed up. And I've been with the same company since 2012. I've got no intention of changing.
So they understood that the Dragon's Den people didn't because it was stupid.
Well, they didn't know what was going to happen. But they headhunted me for it. I got a phone call out of the blue saying, would you like to go on the show? And I went to an audition in London. And they said, whatever you do, don't tell people you get headhunted. We don't headhunt. Well, but they had an agenda. They had an agenda. So on the day of the filmings, my wife, Susan, couldn't come in. And I was on my own. And I was in the den for 2.5 hours, more.
5.
Oh, and it went on, and about halfway through, Deborah Meaden said, shall we start again? I said, yeah, okay. Because I think they were interested, but they couldn't actually get their head round the science. How could you replace this with that? And after over 1,500 reviews, as I said before, you know, people know it works. But it's a learning curve. And the dragons were right at the start when I had a prototype which was held in with clips, and it really didn't look very proficient.
Do you think they regret not picking up?
No. They probably don't even know I exist. But no, it was interesting. You can sort of chalk it up as having done it. No, it's good. But it led to other things. As I say, you need that sort of kickstart. And the publicity was great because I sold lots of pumps. But damn me, the supplier, not Flowflex, but one of the components was delayed. So when Dragon's Den was showing, I had to tell people, well, I haven't got any pumps until Christmas, but I'll put you on a list. And you couldn't imagine, but there was a delay at the port. I manufacture them in the UK, wouldn't do anything but that. And we spend more on testing components than we do buying components. So each component is put through dozens of checks. Pressure tests, water tests, flow switch tests, and I'm probably the only manufacturer who has a guy called Chris who makes every one of my pumps. And it's the personal touch. So if anything goes wrong, Chris, if you're watching this, we know who made it. But no, it's a very good relationship I have with my company, and I've given them the worldwide rights to manufacturing, and works well. How are we doing for time?
6 minutes past 7. Lots more time if we need it.
Right, so I
Did you
need...
just mention about the motor is replaceable?
Yeah, so I believe in sustainability, okay? So if the motor did fail, 4 Phillips screws, unscrew it, put a new motor on. We sell motors for 28 quid. So you don't throw it all out. If the transformer fails, again, you can change the transformer. So it's interchangeability. And I resisted the pleas of manufacturing companies saying, oh, you've got to put screws in that can't be turned, because if not, they won't buy a new pump. Well, no, it's hard enough making something that works without deliberately making it fail. And it would be so easy, because there's a little brain in there counting all the clicks. And if you wanted to really mess it up, you could say, well, after so many clicks, we'll make this product fail. I will never, ever do that. There's no point being wealthy on the back of cheating the public. So the ethos of my company is green, sustainability, and everybody who works for me loves that ethos, because in the office at Flowflex, where I employ several people, or I pay for several people to work for me, I hate all the admin. So, but there are people who are dedicated to working on my project. They are quite happy to continue the ethos of being sustainable and green and all the things that a lot of companies say they are, which is just, it's just words. But we do what we can. So I'll give you a little story, yeah?
Richard had another question.
Oh, sorry, yeah, just before the story, just on the topic of sustainability then, particularly like educating new users to it. So forgive my ignorance, does it work without, so if the pump was dead, would, you know, if on my pipes blocked? Also, if another plumber did come along years later, or I sold my house or something like this system was in there, how easy would it be for a plumber to look at that and say, oh, I know what that is, or I know how to go find out how to maintain this? Are they just going to charge them extra to rip that out and put a bit of pipe?
Okay, so you don't change any of your pipe work to fit this. You cut 110 millimetres of pipe and you slip it in. If at any time you wanted to replace the entire barrel, let's say you got one of the 2012 ones, which are plastic and connections, and you wanted one that is more robust. The nuts are exactly the same, the olives are exactly the same, the length of the fitting is exactly the same. You just slip in a new one and you're away. If there's a power cut or anything like that, then the pump deactivates. Because if the pump can't keep up with the flow, and it won't do if you turn the power off, let's say you've got a power cut, the pump is then pumping diddly squat. When that happens, some of the flow still goes through the flow switch. You saw it flashing. The rest of the flow goes through a full bore 22 mil non-return valve, which opens. So basically, you've got a big non-return allowing 95% of the water to pass, and the extra 5% goes through the pump. So you should notice no difference in a power cut. So your plumber who sees it, unless he's got a big hammer and hits it, he can just leave it where it is, because it ain't going to do any harm. I would hope he actually reads up on the manual and say, this pump was put in for a reason. That reason, unless it's disappeared, means he should be repairing the pump. So, little story. So I've mentioned this to other people. I think it's one of the funnier things. My wife Sue's a director of the company, which means we got on some really amazing overseas journeys. And one of the journeys was to India. And I mentioned this to a couple of people earlier. And we're there selling the benefits of the pump. And one of the benefits was irrigation. And the farmers could save an absolute fortune. Instead of these big pumps, you can use this little one. So we're going to the British consulate, and there's a guy waiting to see us. And I mentioned to the people in the car what I'm going to be talking about. I said, well, I'm going to save the farmers money on pumping. He says, oh, no. He says, the farmers get paid a subsidy according to how much electricity they use. In fact, some of the farmers are pumping drinking water into the sea in order to get the subsidy up. Well, he didn't have to say it, but in my brain I thought the last thing I'm going to sell to a farmer is something to save electricity. So I walk into the room and I say, it's really great for showers and boosting pressure. And it's totally ignore the irrigation. There's no point flogging a dead horse. But it isn't till you get to a country that you actually see the reality of what they're really after. And there's a facade in the UK looking at a country saying, oh, there's a big application there. But when you get there, you find the application disappears. So it's also sort of the way different countries deal with the legislation there. And watermark in Australia is strictly applied by the local council. So anybody fitting a pump without watermark, the plumber is penalised by losing his licence to practice as a plumber. So without watermark, you can't sell a blinkety thing. In New Zealand, same legislation, but they have got an insurance policy which comes with their membership. Should they fit a pump which doesn't comply with watermark, they're indemnified against any action which may take for them. So you go into New Zealand and they say, oh, yeah, great, we'll have lots of them, really great. You go to Australia with exactly the same legislation and we can't touch it, we can't sell it, we can't do anything unless you got watermark. So anyway, watermark was going to be like 10 grand and plus. So I cancelled the patent and we got a good holiday. Well, no, we got a good business trip out of it. But it was a business trip because unless you visit a country, you don't know the reality. You just read what you read in the UK. And who would have thought the New Zealand people were so liberal in their interpretation of legal requirements? Good luck to them.
In the name of sustainability, would it be worth finding someone in Australia who would, I mean, something has to be watermarked there anyway. I mean, they must have pumps in Australia.
I've gone over to pressurised systems.
Okay.
There was a health and safety issue many years back where some plumber did something very silly. Without going through the details, the reaction of the government was to ban gravity systems. Because throughout the world, you'll find the only people who had gravity systems were the people who were linked with the British. So the Irish have got gravity systems, Cyprus has, Australia and New Zealand had. Other countries had pressurized systems and never went to gravity. But the wonderful thing about gravity systems is after the war, it was thought that every house should have at least 1 day's storage of water in the actual house. So the idea was that your tank in the loft would keep you going if there was a failure in water. So everybody, because they needed to comply with this legislation, put a tank in the loft. The Irish followed us, as they would. In fact, we actually controlled Irish citizens or legislation. Cyprus obviously followed us. And as I travelled, we've been all over the world looking at applications, but the common link is this legislation which came out just after this First World War, which is why we got gravity systems. I love them, but yeah.
Did the Indians end up using it for irrigation?
No.
What about in Africa?
We've sold pumps out there, principally for pumping raw water from rivers, and then to a header tank, and then boosting them. There's a children's home in, I forget the name of the place now, but we sold them all over the world.
But could they be used for irrigation onto fields then, or they're just not big enough?
Well, they could be. You'd run them with a solar panel. I mean, the origin of the pump and why it's so robust was, I came across it because of solar thermal. I needed a pump that would take huge temperatures. Is huge a word? High temperatures.
It's a Norfolk word.
Yeah, good word though. So I needed a high temperature pump.
Yeah.
And then I sort of progressed from there. And then, having got the high temperature pump, I then needed one which targeted the sweet point on what people needed for showers. And after that came all the developments, making it stronger, better, flow switch, all the things. But I've often visited places and I come up with ideas, either through trying to fit the pumps myself. And for instance, the cables. I was on a job where they didn't have a power supply up in the loft. And the beauty of it is that I work with a really big manufacturer, biggest manufacturer of brass fittings in the UK. So I say, look, there's a market for these. And they say, yep, how many do you want? As an individual, you can't do that. But having a product which is proven, you get a certain degree of credibility. And I wouldn't have known that this cable would be so useful unless I'd been on a job and stuck with a solution where it needed to be plugged in downstairs with a transformer, and the pumps are upstairs. So what it's done, it's sort of morphed through the years, and every time I come across a problem, I think, is there a solution? And I just tweak it a little bit. But I don't think this pump's going to get any stronger now. It's reached its pinnacle. And I don't change things unless I need to.
Yeah.
So. No more questions. Well, shall I give you another story? What one do you want? We have got something to give out. The best shower head. Seriously, I sold these for £15 on Wright Choice shower heads, Wright Choice shower heads. In order to get a really good shower, you need enough jets to give enough water at a speed that gives you a refreshing shower. Now, if you have less jets, you can also get a good shower, but you start getting over that sweet point. And to get an effective shower, you need 6 litres of water and 2 or 3 metres head to give a good spray pattern and plenty of water. Now, if you think that 8 litres a minute is the sweet point, then I would have made the pump bigger. And if you want 12 litres of water, then I'm afraid you're going to be paying twice as much for your electricity and water than I am, having a very good shower. So the perfect shower is at a sweet point, and the shower head meets that. And this was the shower head, or different manufacturer, but identical in design, which I used at Cranfield University. And I used about a dozen different shower heads for the pump I was using. This came out heads and shoulders, so I thought, great. So I bought a load in China, but there's a story behind that, which I won't go into great detail. But quality control is always an issue with overseas purchases. Do not go crazy until you get samples that you test. So I did catch a cold on that, but I did sell so many of them, or have sold so many of them, they don't owe me anything now. But they are definitely a gift worth £15, and you'll each get one of those, and a leaflet about the shower head and the hose. And a leaflet, it's an old leaflet before a lot of the improvements were made. But I'm always doing things. I mean, I've got this heat store in my house, which I had manufactured 3 years ago. And you heat it up, and then 3 full days after you've heated it up, there's still enough hot water, plenty of hot water from a shower. So it's a 500-litre heat store in my house, because that's what I do. I wanted to prove that you could actually harvest energy from the sun in an effective way by using a heat pump. In fact, that was my very first invention in 2008, which got so much interest that the development of this pump was delayed because the solar thermal invention was the one that was getting all the money. And developing this pump was very, very difficult, because I couldn't even persuade angels. There was one professor in Wolverhampton University said, the effect of the pump is transient, the science is not robust, and he wasn't interested. So I actually made it in the end. And I made it, and then I said I wanted to do the verification in Cranfield University. So they invited me to the university, and he said, well, we invited you along because we wanted to laugh. And I showed him the pump, demonstrated it, and he sort of went quiet, and about halfway through the coffee, the bell, you know, drinking the coffee, the penny dropped of what I'd done. Because the thing with water is you have to get the right flow with the right state of water. If you know the 7 bore, you've heard of that, where the water suddenly whooshes up and there's a wall of water. It's because the water goes from laminar flow to turbulent flow. And if you get the hydraulics right, you can do amazing things. And pretty much 100% of the energy that this pump uses is to make your shower good. This one, well, maybe 10% of the energy goes to make your shower good, because it's just wasting. It's because plumbers like big pumps. But this literally was taken out of a house and replaced with 2 of my pumps, albeit that was back in about 2013. And the latest customer review, 5-star on that, said he replaced a 3,000-watt pump with 2 of these.
But why was the professor thinking it would be transient, and why is it not?
Because I hadn't built it at that stage.
Yeah, okay, but he must have had a theory, and his theory was obviously wrong. Where did he go wrong? Do you know?
I hadn't built it.
Yeah, but he had a strong belief, so the theory...
You see...
The professor, his theory said this is not possible. I mean, I accept that you proved him wrong, but I just wonder where he did go wrong.
The efficiencies are very, very considerable if you treat water in the way that the Victorians did. And back in the day, when I was with Anglian Water, my job was to rip out all of the Victorian technology and replace it with electronic circuitry and inefficient systems. But I got to see that the Victorians could do all these amazing things with water with very little power. The guy at Wolverhampton hadn't been down to see what I saw. So when I look at water, I know what I've seen and the sort of things I can make it do. If you ain't seen it working that way, you wouldn't know. So it's the background that opens you up to things which are almost impossible.
You should put the shape of water in your next title.
One of the funny things is Anglian Water, they used to give me all the, well, they gave me very interesting jobs. Basically, anybody who didn't want a particular job got it passed to me. And one of the things I did, which was very helpful, was low energy water pumping. And I worked out that you could save a huge amount of money by reducing the flow rates and pumping constantly over a day. But the project was flawed because Anglian Water were actually pumping water very, very inefficiently at night in order to burn off surplus electricity. So they had a contract with the energy suppliers to waste energy at night. And then I come along, just like the Indian situation, say, look, you save all this money. No, we don't want to save energy because we've got this contract where we burn off the energy at night. And it made sense to them. When you looked at the economics, if somebody says to you, you're going to get cheap energy provided you burn all the surplus off at night, you do what is economically viable. But I should never have been given that project. But that project, you know, is in my head. I sort of knew that there was potential in the invention simply by much, much bigger pumps. In fact, at Cranfield, my little pump, I was next to pumps the size of double-decker buses. It was really funny, this little pump in this huge laboratory with these huge pumps. But I was there. Have we got time for another story? Pick one.
So it doesn't sound expensive, the pump. I mean, it's 125, 150, 200 pounds or whatever.
Yeah.
How long before it will pay for itself?
You mean if
Well,
you replace it against
Yeah,
instead of the big one, you
Yes,
have the
because
small one?
you're saving money on the energy.
It depends how many showers you have a day.
Depends on them and it's difficult to say.
Depends what your source of heating is.
Yes, yes.
And I'm a pragmatist. If your power shower's working, right, then probably just leave it. But next time you're thinking of replacing it, you know, think ShowerPowerBooster. And you'll get a quieter pump, you'll get a more economical pump. But if it ain't broke, don't fix it. So that's not the way to sell pumps, I know, but that's me. And
I think it was just a theoretical question.
Theoretical.
you leave your pump alone. If Lutzi says leave it, sorry, Paul.
I'm much more thinking about the agricultural, using it for irrigation or something like that.
Just do your calculations.
You sure?
Yeah, just little pumps with storage at the end will beat big pumps with no storage. But your capital costs of providing that storage could be horrendous. So in Anglian Water, I think we've taken a lot of the storage out. I've got Chris Breton here, who used to work with me. I mean, we've taken a lot of the service reservoirs out because of other issues become more important. And there's issues of contamination in water towers. So part of my life has been ripping out Victorian monuments and reducing storage and replacing it with pumps. But you do what you're paid to do. And that was interesting. I worked for 3 water companies, Anglian Water, Northumbrian Water and Welsh Water. And it was interesting seeing the approach of each organisation. And just to say, when you work for a company for a long time, you tend to think they're got full of faults. You know, you think what they're doing isn't efficient until you work for another organisation and you think, wasn't that organisation that I've been criticising all these years wonderful? And then you work for a third organisation and think, well, heck, Northumbrian Water were a pinnacle of expertise compared with the final guys I worked for. So bang goes all my sales in Wales. So I sort of messed that up. But no, it's nice to have a worm's eye view. It's like when you visit countries, you find out what the real truth of the market is. When you work in actual companies, themselves, you understand the ethos, and it's a funny old world, but it's so easy to criticise your own employer just because you've been there a long time. But the world is what it is. I used to do mineral recycling. I set up several companies, and there was a mineral recycling company I set up. And the worst job I've ever seen was a load of guys working in basically a cow shed. But there wasn't cows because it was next to pigs. And they were working on this farm, refurbishing these units to grade excavation from roads. And it was cold. It stunk. And they were working there, and there was no facilities. And I thought, the best job in the world, the worst job in the world, and I've probably seen it. And but there again, you know, you don't see that unless you get into a certain position. Like the Cypriots tried to recruit us to invest in Cyprus. So we got wined and dined in some place. And the only thing going for it was that we could save tax if we moved to Cyprus. Well, sorry, mate. If you can't move all the way to Cyprus not to pay tax, then you got the wrong product. Now, so to conclude, I manufacture in the UK. I may not be the richest guy in the world, but I got principles, and principles help you get to sleep. So thank you for coming along. I hope you enjoyed it. And bye for now.